Um, you know that I like my highlighters, right? This is kind of what's happening when you do invest, when you work with investments, right? You've got perhaps a large deposit that you've made, right? So this is usually a larger amount, a one-time deposit here. I want to start with $500, okay? Your investment starts. On top of that, you may add regular deposits, right, on regular intervals. So it could be every month, every week, every 2 weeks, right? So you add more to your account. And on top of that, right, remember, whatever you have in your account earns interest. So you could stack that on top of everything else if you had it, right? Like, I mean, interest should always be there, or else why would you be saving money? Okay? So potential, like, you could have a scenario where you only have a large deposit and no regular deposits, and this whole thing in terms of the principal is what you've put in. Principal is the money that you put in, that you put aside. That's your money, okay? And the growth, the interest that you've earned, right, that is over top. That's the bank's money. They gave that to you for saving, okay? So in a sense, the principal plus the interest that you've earned, and we can use this sum of interest function, okay, or we can use the formula. It's up to you. That gives us all the money we have. And how do we check how much money we have at any given time? It is right here, balance, and then you go years times whatever PY is. So that's what balance does. It figures out the money you've put in and the interest you've earned is this much money, right? So there will be, it could be the entire investment. So let's say it's a 10-year investment, then you obviously would go 10 times PY. Or you could just say, how much money would you have 3 years into your investment? It'd be 3 times PY. So I hope this kind of just gives you a little bit of a glimpse, like what is happening here, right? Oh, I should also say, sometimes there is no large deposit. You start with 0, and you just make a bunch of small deposits, right, over the life of your investment. That is also an option. So keep that in mind. Let's go to 45. 45. The grandfather of a newborn child invests $2,000 in a GIC that pays 6% compounded semi-annually. Use a TVM solver. What amount will the child receive when they turn 21? Okay, I want to tell you something, remind you something, because yesterday you were probably like, stop talking, I just want to have lunch, right? You may use the TVM solver anytime. Anytime. You ready for this part though? Please do not use the TVM solver if we're dealing with simple interest. You got that? If it's a simple interest, you cannot use the TVM solver. You have to use iParty or the other one, A equals P1 plus RT, okay? Some sort of party, a different party. But please, you can use the TVM solver for any other scenarios, but don't use the TVM solver for simple interest. That's all I'm going to say there. Okay, using the TVM solver, how much will this child have at 21? So let's do that. And I'll be pretty good at this at the end, but this is fresh again for me. So I'm going to go find apps, finance. So it's NIPV. So you always have to show me these entries if you want to use the TVM solver. Okay, so you have that lined up. Let's start with the bottom. Compounding periods per year. It's compounded semi-annually, so that is 2. Payments per year. Are there any payments being made? other than the initial amount, there is no regular payment, no regular, like I'm not making monthly contributions or anything else. So then these are the same. Okay? That's all I'm going to say here. Future value, that's what they want us to figure out. What amount will the child receive when they turn 21? So that's our dot. Okay? Payment, we don't have any. Present value, you investing it, right? $2,000. So that's minus 2,000 like that. Okay, it goes away from you. Interest rate, 6%. N is always years times PY. How many years are we talking about? 21 years, right? Because newborn to 21. Then that's what you have there. So it's 21 times 2, right, which is 42. We good? So I take my calculator, I plug everything in, future value, 2 and 2, and I go to future value, I hover over it, I go alpha, enter, and there it is. It's 6,921 and 39 cents. Okay. So that's how much money you would have at the end of your investment. Okay. Let me just go check 45. Is that what the answer said? I hope so. Yeah. So this is how much a child will have at the end of at 21 years old. B. Using the formula, calculate the value of the investment when the child turns 21. Compound interest formula, I mean. Okay? That's the one here. It's just so you see that they're doing the same thing. Principal is 2,000. 1 plus 6%. Here you have to turn it into a decimal. And n is 2, so we divide by 2. And then it's 2 times 21. That's 2,000. Let's do this here. That's 0.03, right? Plus 1, that's 1.03. And this is 42. And you may enter this in one shot at this point. Like if you want to go 2,000 times 1.03 to the power of 42. There you go, 6,921 and 39 cents. Okay, so they both give you the same answer. Listen to this part though. Some students might think after this, oh, so I can use TVM or compound interest, right? I can use the formula or this. Only if there are no payments being made. Compound interest, this formula cannot account for you making additional payments along the way. It just cannot, okay? So this is limited to just a one-time investment and then it just grows on its own. So then you can use either one. I will just tell you this, I almost always gravitate towards TVM solver. You become a financial advisor and you're like, yeah, how much money are you talking about? How much you want to deposit? I'll tell you, boom, here's your answer, right? So you just like play around with it. And that's that. Let's do 3. I was asked to do homework check, so this is your homework check. Jesse invested $5,000 in a savings account, 2.25% compounded semi-annually. How many years would it take for the investment to double using an exponential function? Okay. You don't have to be overly worried about this, but I think you should know how to deal with this. Using an exponential function, we kind of use this to get us started. Okay, we use that to get us started. That's like the exponential function when it comes to finance. So we would say I will let y instead of a equal principal is 5,000. This will be 1 plus, the interest rate is 2.25. Please don't fall for that. That's just 2.25%, okay? So 2.25, that would amount to 0.0225 over compounded semi-annually, that is 2 times a year. And then it's compounding periods. And for time, I use x. So x is basically substituted in here. So now we have you can enter it exactly like this. I will clean it up a little bit more. I don't like all of this in here. So I'm going to go 5,000. And I just basically go 0.0225 divided by 2, add 1 to it. That's what goes inside the bracket. 1.01125 to the power of 2x. Morning. How do we find doubling time if you have an exponential function? You let y2 be twice of what you started with. Okay, so 2 times 5,000, which is 10,000. And then we're going to go second, trace, intersect. I think it's good to not forget about our good old exponential function. I already have something exponential in here, so I'm just going to change this. This is 0.1125. Delete that. And then at the top is just 2x, okay? Like that. And I'll let y2 be 10,000. If you have the same graph as I had yesterday, this should work for you. There's your exponential. There's the 10,000 mark. Second trace 5. Enter, enter, enter. And our doubling time is 30.979, so it's 30.98 years. All right, that's A. B, how many years would it take for the investment to double using your TVM solver? Okay, this is actually good practice. Let me just zoom out a bit. TVM, so we got to go NI, PV, PMT, future value, PY, CY. And this one I didn't show you enough yesterday to do this one. But that's why homework is nice to kind of try it, attempt it, and see how it goes. It's compounded semi-annually. There are no payments being made, so PY is the same as CY. Future value. What am I going to put in future value? I know that present value is 5,000 negative. So I'm wondering, how long would it take me to double that investment? So basically, if you want to go with an arrow here, I'm going to go times 2. Why is this negative again at PV? Because when you deposit it, bye-bye money, right? It's leaving you. But future value, when it's done, it's going to come back to you. So that's why this is positive, right? So these three guys, they always have to have a sign attached to it. Okay? Payment, there is none, 0. Interest rate is 2.25. And so what does that mean? What is the only thing I can solve for? N. It's the only thing I can solve for. Do you remember what N, how do we come up with N every time? Years times PY. Do you remember that? So the years are always hidden in N. Inside N is where you're going to find the years. So let's figure out what N is. Apps, enter, enter, put all that stuff in. You can just overwrite. You don't have to clear, okay? Negative 5,000, 2.25. And I'm going to go to N and solve for it. Alpha, enter. It's 61.9590 something. But that's not the years. Okay, that is not the years. This is years times PY. So to figure out the years, we have to go N divided by, bless you, divided by PY. Does this make sense? It's too early in the morning, right? Because remember, N is always years times PY. Like if we want to fill it in, if we want to fill this ourselves, this is what we do. The number of years times whatever PY is. And so using this formula, PY basically comes over to this other side here, dividing. So it's N divided by PY. So this is what's going to help you here. So years is 61.95901 divided by 2. Guess what you're going to get there? 30.98 years. C. You know what? I'm going to do C over here. How much money, how much would you have after 12 years using the TVM solver? What would we use to answer this question? You got to use balance, okay? Balance 12 years times whatever PY is. PY is 2. So you want to go balance of 24 is equal. So we're going to figure out how much money is in this account after 24 compounding periods. So grab your calculator. You got to go to your home screen. And then you want to go apps, finance. Don't go TVM solver. You got to go balance. This one here. And you got to type in 24. And it will tell you that it's 6,539 and 96 cents. Just so you understand, this is based on whatever you have in your TVM solver right now. If you change the values in the TVM, this is going to change. So you got to make sure you don't do that, right? Like this is now based on the previous work we just did, okay? All right. D, what is D? How much interest would you have earned in the first 3 years? Let's do that one. I think I did this differently on my key. I know that. I know I did this differently, but that's fine. If you did the homework, you get the same. Interest. Sum of interest is what we're going to use here because you're not finding the entire amount. You're just finding the interest in the first 3 years. So we're going to go from start, and we got to give it an end. So naturally, the start is going to be the very first compounding period, and we got to go years times PY as well. So this is from the very first one to, we're talking 3 years, and PY is 2, right? Way too many sum of interest, right? 1 to 6. So from the first compounding period to the 6th compounding period. So grab your calculators. You should, right, be on the home screen for this one. We go apps, finance, and you got to go all the way down to sum of interest, that one right there. And then you just go 1, 6. So this one needs a start and an end. Balance does not. So you will have earned $347.14 at that point.